Cool. Yeah. So we're going to talk about a simplified component model. Basically, the work that we're doing inside of Stencil, how that can help you in your day-to-day kind of work. Maybe this is something that is valuable for you if you are coming from different uh, from a company with different technology choices. And if it doesn't seem applicable to you, maybe it can help you figure out where the future is going. That seems to be the common theme of looking at the past and seeing the future from past experiences. So let's continue with that. Before we do jump into anything, if you have any questions, please tweet at me at mhartington. I'd love to know your thoughts on this if you have anything after the fact. And I'd be disappointed in myself if I didn't get a chance to show off this amazing photo of Wasim and I a couple years ago, about ready to drop the next big rap album. As we look so cool with steam coming down from the misters. Love you, Wasim. So let's move on. That was the only reason for that is because I had that photo. Let's use it. Cool. So first, let's kind of ask a question that might seem pretty vague. Why? Why should we care about component models? Why should we care about what we can do to make things simpler? Where did these components come from? Like, think about all the questions that you could propose when you think about component models and you think about components in general. So if we go back to a long, long time ago in the yesteryears of Web 1.0 and slowly Web 2.0, we kind of have components on the web, even if we didn't think about it in that same sense. If you use the video tag, congratulations, you are now using a component. The select tag, the input tag, most of these HTML elements are glorified components at their core basis. If you look at the video tag in Chrome, for example, you're going to see all these different DOM elements and nodes and different ways that you can control the play, pause, the track on a video, all from the fact that you just gave a video element a source, either as a child tag or as a property on that element, and you got all this for free. Same thing with select, same thing with input. You get a lot of this built-in functionality for free based on the fact that it's just encapsulated into these tags or into these components. Now, this kind of concept of encapsulating functionality in either tags or predefined kind of components really started to inspire a lot of developers and a lot of library authors that that were working in this space. For example, jQuery. This would probably be everyone's, I would say, quote unquote, first framework. Even if you didn't look at it like a framework, people used it like a framework. And its huge reason for it being so successful is because it made the web a less hostile place. You could do DOM selection. You could do all this amazing stuff with this simplified approach to querying for elements. And probably its key feature, and something that I think really made jQuery stand out, was this idea of a plugin, where you could have this component, quote unquote, or this set up kind of functionality, and you could attach it to a DOM node quite simply. So if we look at like the traditional hello world of jQuery, minus this import statement, which I was not aware that you could import jQuery. I didn't realize it was that hip and cool and up to date on all these awesome things. But we have this approach of using this $.fn to create our own custom functionality and append it onto the jQuery prototype. So here we can just say $fn.helloworld is going to be a function. We'll take the DOM node that we are referencing or passing in, and then we're just going to append hello world to the DOM node. So then when we actually want to do that, we'll just target, let's say, a div with an ID of app. Seems to be the standard thing that all frameworks do these days. and we could just say hello world, and we got hello world there. This, in its sense, you know, gives us the basic building blocks of a component. If you think of all the slide carousel libraries that are out there, the image viewers, they all operate on the same functionality or the same principle. Backbone came along and took this a step even further and said, what if we got rid of all this kind of boilerplate that we saw people doing and still allow you to use jQuery, but have this idea of composing things together? And they did this by saying, why don't we create this view where we can extend it and create custom views that people can use? So in this case, we have app view, and we're going to extend the built-in backbone.view, and we're going to get this initialize function, which is going to be called for us. We can think of this as our ng on init, or our component did mount or mounted in view, where we are just saying, hey, this is a lifecycle hook. And then we're going to call this thing render. Render is just a name. Modern frameworks these days use render as well. All we're saying is that inside of render, we're just going to take the element that we pass in and set the inner HTML to hello world. Now, we can create a new instance of this by just saying new app view and passing in a DOM node. We could do multiple variations of this, where if we just say app2 and copy the DOM node, we now have multiple instances. And all we're really doing is just targeting a DOM node. This is eventually just saying div is app2, or giving us a precursor to a custom element tag. And this really paved the way for ideas that we see today. And I do want to take a moment to stop and call out AngularJS as being, I think, the biggest impact on custom elements on the web, and this idea of a component model, where instead of giving you functionality that you have to manually attach to a DOM, AngularJS said, hey, what if we had directives and you could pass in a actual tag name and just use that tag name to instantiate all this custom functionality? This really brought us closer to the idea of, I could have my video, which extends the built-in video element, and we're just creating all this custom functionality. And users don't need to know about the progress bar, the play pause button. They can just use that tag, set a property on it, and then pass in the data through those properties or attributes. Now, if we fast forward to today for reals and look at the modern frameworks, they all kind of took this component model and said, yep, components are the way to go. But they did it all in a very similar way that is incompatible with one another. And if you don't believe me, let's take a look at the big three, Angular, React, and Vue. If we look at the Hello World version of Angular, we have this definition for what a component is, the tag name, its internal template, and then a class for some custom functionalities. Fairly straightforward. React. Well, instead of giving it a tag name, we just utilized the function name as its tag, and instead of a template, we return some JSX. We're still using this React DOM.render method, something we saw in Backbone, but we are just giving it the element that we want to target, and we want to render this component into using React DOM.render. So we have our component tag name, template, more or less, and in React, we have different ways to do styling. Now, Vue says, okay, what if we had a literal template tag as our template, a script tag to define all of our different logic, and then a style tag to define our encapsulated CSS, and we just did a single file component for all of this. So if we could look at all of these different approaches, we're going to get the same thing over and over. We have a way to define the internal template and logic of our component, the tag, and a way to create associated styles with this. Now, those are just the big three, and I'd be remiss to say that there's more than just those big three frameworks out there. I'm not going to try to say this all right now. it's a lot, and you probably have heard of all of these. But note that all your real modern frameworks that are out there, they all kind of follow the same idea of creating some custom functionality and having this template. They have that component model as a core thing, but why? Why are we creating multiple frameworks that do the same thing, but in a totally incompatible way? Now, this has, I heard of this phenomenon from somebody, and they called it the pink wheel syndrome. Essentially, you're not reinventing the wheel, you're just making the same wheel and painting it a different color. Like, you're not doing anything groundbreaking, you're not doing anything that's so drastically different, you're doing the same thing over and over. Is it better? Probably not. Is it different? It just has a fresh coat of paint. So frameworks that frameworks that come out every other day that keep pushing this idea of having this component model, it's all great, but we are constantly working against our own best interests by creating them in an incompatible and non-interoperable way. If that's even a word, non-interoperable. So this is where we get our standard XKCD. There are 14 competing standards. What we need to develop one universal standard that covers every use case. Soon there are 15 competing standards. So web developers and browser vendors kind of came together and they said, hey, we can't get into this situation where we have 15 competing standards because we decided that we wanted to make our own. Let's kind of cover the bases, not cover every use case, but let's create some core primitives. And what if we took all these primitives and baked them into the browser? That way frameworks, library authors, component authors could all utilize and build on top of these to create something that is compatible with all frameworks. And that's where we get web components. Now, web components, you probably have heard of them before. You probably think that this is the full standards name. And I want you to, kind of think about web components as being the EU. Web components are not necessarily a single standard, but they are a collection of standards. Much like the EU isn't its own country, it is a collection of countries together. So web components are built up of a few separate standards: the template API, custom elements, and shadow DOM, giving you these low-level building blocks to do inert pieces of DOM, custom elements for defining your own tag, and shadow DOM for encapsulating your component internals. All those kind of fall under the umbrella term of web components. And the goal is to create these APIs that way framework authors could utilize them internally and support everything that they need to do. If we go to customelementseverywhere.com, you can get a kind of gist on how supported are web components in different frameworks. I will say Angular, Vue, and Preact have excellent support. React has kind of iffy support. So maybe that means that React just needs to have better support for web standards. That's not an argument I want to get into, but I'm just going to say maybe. So if you thought about this before, is this a Google or Chrome only thing? Absolutely not. This is a cross-browser effort. Chrome engineers did lead the way, but we had support from our friends over at Microsoft and Mozilla. And I feel like this is a rare moment where we get to call out Apple as coming in and saying, this is great, let's push it even further and do something better. And that's why we have web components the way they are today. So all four of the big browsers out there, your Chromium-based browsers, your WebKits, and your Mozillas, they all support custom elements. If you've heard of Polymer before and think, oh, Polymer equals custom elements or web components, it's not exactly the same thing, and we don't need to get into it, but note that Polymer is just a different variant of writing custom elements. So let's take a look at our very, very first custom element and how this actually relates back to our our approach of doing hello world. So we first want to start off with this class where we extend the built-in HTML element. This is more or less our glorified div, where we say we'll instantiate the base element, and then we will say, give me a shadow DOM, where I'm going to encapsulate all of this hello world's internal template and hide it from the users. We have this connected callback, which essentially, again, is our ng on init, our component did mount, our use effect, our way of just saying, hey, our component is rendered. Here's a callback that you can do something with. And we'll just say this.init. This.init could be this.render. It could be many things. It's just a name. And then in here, we're just going to say, give me the shadow root and set the inner HTML to be h1 of hello world. And we can define that custom elements on the browser or on the Windows root scope. So we'll just say window.customelements.define, give it our tag name, our class, and then inside of our HTML, we can just use hello world. Now, it's important to note, we do need this hyphen here because we need to tell the browser that this element is not necessarily a built-in, but something that is custom, that is a little bit more. Now, if we go to a more, I would say, complete example, this is a tag or custom element called Better Image by my friend Pearl. If you go to github.com/pearlbay/betterimage, you can see this web component built out in various different frameworks and different tools. Essentially, it's a way for us to say, I want to have a single URL for our main image, but if this URL fails, let's fall back to a different URL. So here we're saying we have an image tag with the alt text of an adorable animal. And yes, this animal does look adorable. But what happens if, for instance, we fat finger our URL and we just say, oops. Well, we still get an adorable little animal, this time Nicolas Cage, but we have a better image or fallback URL where we can have that loaded instead. That way users just don't see a blank square. Let's go back. Now, inside of here, we have a whole bunch of pieces involved to get an inner template, to observe the properties or attributes on our element itself, and react to whenever they change. So for instance, we can observe all the properties that are on here, and then whenever they are updated, we can manually update all those. A lot of this is just connecting the properties and attributes from the element tag and setting it on the template itself. So we get a lot of built-in niceties here, a lot of approaches that are better than the old approach and framework-specific things. And these are all built in. But I don't know. I like web components and I love custom elements. I think they're a great approach, but it feels very low level. And that's kind of by design. Web component browser standards said, hey, web components, they should be low level. You should be building tools on top of them, or framework authors should be using these instead. So some things that I have that are kind of, gripes. Updates aren't optimized. So if you're constantly doing read, writes to your internal template, you're not doing any diffing or smart diffing of that DOM. So no virtual DOM or incremental DOM if you're coming from different frameworks. Properties are not smart, meaning that unless you set up an actual observer to observe changes on a property, you're not going to automatically have that reflected onto the element. So this is something that you need to manage, which, cool. I mean, I guess I can, but it's just not something I really want to do. And yeah, the overall message is they're just very low level, too low level for myself. And this is where we come into Stencil. We take all the goodness, I think, that web components have, and we say, let's simplify just a few things of it. So if you think about what Stencil is, it is a compiler for web components. basically saying we give you this abstracted API, and you can take this abstracted API and generate web components from it. So if you're used to things like ANGULARJS directives, decorators, or React's render function, this should feel pretty familiar. So it does use JSX and VDOM for diffing and speed, but it also has reactive properties. So anything which comes from Vue. So any changes that happen on them, they're automatically updated. And important to note, Stencil itself is not necessarily aiming to be a framework. While you could possibly use it in such a way, note that it's not a goal to be as comparable as Angular, React, or Vue. It's simply meant to be a way. It's like, we need some components that need to have X, Y, and Z, and that's what we built it for. So let's take a look at what this actually looks like. So here we just have our component, where inside of this component, we have a tag of my name and then a link to some styles. So this should feel pretty familiar for the Angular folks. We just have a way to use the component decorator, the tag name, and style URL. For our class, we are exporting out this class, which has a property that is decorated with this @prop decorator, meaning that anytime name changes from outside of this component, it's automatically going to cause a re-render. And down in our render function itself, we're just going to return some JSX and do some standard data binding to render this out. Usage for this looks pretty familiar. We just have my name equals Mike, and then we close it out with that tag. So let's kind of skip the slides and let's go to a quick demo while I still have some time. If I can find out where my browser is. There we go. So we're going to come over here to our component demo, and let me just quickly set up some splits. And inside of our code, our project, we just have this component with the accompanying JSX. Now, this is a little bit more fleshed out than our component example inside of the slides. So we'll just run npm run start to see what this looks like. And as you can see inside of here, we have a little snarkiness. Hello world, I'm Stencil. Don't call me a framework JS. So we have these props for our first name, middle name, last name. We have this get text function to format everything, and then we have this render function. So we could change this on the actual index.html itself, where all we're doing is just saying, setting those properties, and we can change that. What's even better is if we open up the DevTools, and if we go and select the component and then go to our DevTools, we can see, let me bump that size up a little bit. We can see we have the component itself, but we could say, oh, $0 dot first is going to equal Mike. $0 dot last equals Hartington. So we have a lot of work in here to just be able to mix all of these different approaches and different ways of saying, I have a component, it has some properties. Whenever those properties change, I don't care where, just automatically update and re-render them. Now, this goes as far as being able to also do things like custom events. So we could mix our properties and our custom events and do something like watch and event. Nope. Come on. There we go. That's what I get for using Vim. We'll just say we'll have a custom event called did change, and it's just going to be an event emitter. And then we will say, oh, let's just watch first. So whenever the first property changes, and we'll say on first did change, we will just console.log new name, console.log old name, and we'll get those values from all the arguments. So think new, old, new, old. And then we could also do something like why is that not looking correct? Probably don't use new.
Reserved keyword, Mike.
Thank you. Let's just try to be smart here. We can just say this dot did change dot emit, and we can emit any data from here. So foo, we'll save, figure out why this failed, because this needs to be a function. And then we will go back and we will check this out again. So let's just say we'll grab our element and we'll say $0.first equals foo. And our actual change didn't happen. Okay, well, it seems like we got some demo gods coming in to fail and prevent me from doing everything correctly. So we will kind of just move on just to be sure. But we can wire up all these different events and all these different props and then have them be adopted into the various different frameworks. Since we're close on time, we'll just kind of continue on. Now, there's a few different APIs that we have in here. State, for instance, is a simple one to prop, except this can be mutated internally. Prop cannot be mutated internally to the component. Watch will allow us to connect callbacks to whenever properties change, element to grab the direct DOM node, method for exposing custom methods, events for custom events, and listen for listening to global events. So this kind of gets us to the point is like Stencil is here to solve those problems that we had with custom elements and make building low-level components simpler. Just make sure that they could interact with these different frameworks, make sure that they were going to be fast no matter what, and that we could build these on top of stable APIs like custom elements and everything. And there's a lot more in here. So as I mentioned with customelementseverywhere.com, we see excellent support from Angular, Vue, and Preact. React has less than ideal support, but we can polyfill that inside of Stencil's compiler. So that way you get, instead of just web components, you get a flavor of React components that proxy out to the low-level web component. Not ideal, but maybe if people bug the React team enough, we can get support for that. And then web components has a build target. Angular Elements still is around and allows you to take your Angular component and deploy it as a web component. So if you're an Angular fan and you want to stick in that mindset, you can use Angular Elements. Vue has the same approach with web components as a build target, though both of these approaches at the moment kind of just say you need to bring in the whole library. So this kind of common API and the simplified way of creating components, whether or not you use Stencil, most major players agree that this is something that should be worked on, and that this is important to the web ecosystem. And, you can think of it as being web components being the primitive, Stencil and all these other approaches to doing web components are just a slightly different abstraction on top of them, and that web components themselves really are the big thing that you should be worrying about or that you should be noticing. It gives you all of the flexibility that you would want. If you want to see it in the wild, obviously we're using it inside of Ionic. Porsche is using Porsche or Porsche, depending on how you want to pronounce it. They use it. Amazon also uses it. Uses it internally for their AWS for the AWS Amplify stuff, as well as Apple. Again, Apple only uses things if they have a need for it. So it was great to see Apple using web components and, of course, Stencil. So use it if you think that it's going to make sense for your team to be able to have cross-platform components and components that are simplified and easier to maintain. Or don't use it. Just figure out what makes sense for your team. But do realize web components are here to stay and that these things are going to be important and you should know them. Thank you.